Hi guys, tried to give you a little more help with this chemistry packet for chapter 6. In here, you guys are drawing the electrons in. So if you do sulfur, you have 16 protons, 16 neutrons. So you need 16 electrons. Electron is 2. You get 8 in the next shell. And then you would need 6. Because sulfur would like to gain 2. It would like to be full with 8. Beryllium has 4 protons, has 9 total, so you have to subtract 4 from that, you get 5 neutrons. It has 4 positives, so 4 negatives, 1 electron, 2 electrons, you need a second shell, 1 electron, 2 electrons. This is one of those cases where it's easier to lose the 2, so beryllium would gladly send its electrons to the sulfur, and you would actually get beryllium sulfide. Nitrogen has 7 neutrons, so you need 7 electrons. 1, 2, 1, 2, 3, 4, 5. Sodium has 11. 11 from 23 gives you 12 neutrons. 1, 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you need 1 on its outer shell. Alright, the last 2 on this page, you have potassium has a 19, atomic mass of 39, so you got 19. 19 minus 39 gives you 20 neutrons, so I need 19 electrons. 1, 2, then you need 8 in the next shell. 1, 2, 3, 4, 5, 6, 7, 8. That gives you 10. So then you go 1, 2, 3, 4, 5, 6, 7, 8. You need 1 more shell because that only gives you 18. And on this last shell, there's 1 electron out there just waiting to go away. Argon has 18 protons. 18 from 20 gives you 22 neutrons. Start your first shell with 2. The second shell gets 8. And that would give you 10. So you need 8 more. 1, 2, 3, 4, 5, 6, 8. This one is full. As a full valence shell. I showed you some of these before. So this one has 8 in its valence shell. That one fails to react. This one has 7. This is going to gain 1. This one only has 1 here. It will lose 1. This one has 2. It only wants 2 in that shell. This one is full and will fail to react. This one has 2 in its valence electron. You would rather give away those 2, so it will lose the electrons. In this case, it will lose 2. Here you have 1, 2, 3, 4, 5, 6, 7. So 7, it wants to gain 1. these, you're just balancing your numbers. So magnesium loses 2. Every time you lose 2, you become a positive 2. Bromine gains 1, so it becomes negative 1. I need 2 negative 1s to balance this. So this becomes an MgBr2. That's a subscript. Sodium has a positive 1 charge. It loses that 1 electron. Oxygen wants to gain 2 electrons. So you become a negative 2. I have 2 negatives, 1 positive. I got to balance that. I need 2 positives, so I need 2 of the sodium ions. Na2O. Lithium becomes positive 1. It loses that 1 electron. Oxygen again gains 2. It's going to look exactly the same, only instead of being sodium, you've got lithium in there. Calcium has 2. Calcium will lose 2. You minus 2, you become a positive 2. Phosphorus has 5. It ends up gaining 3, so it'll become a negative 3. This is one where you need a number that 3 and 2 go into. Well, it's 6. So I need 3 times 2 to give me 6. So I need 3 calciums. I need a phosphorus times 2, because that negative 3 times 2 will give me negative 6. So this becomes P2. In this case, carbon becomes positive 4, because carbon can go both ways, but depending on what you react it with. Chlorine is a big, strong atom. It wants to take an electron, minus 1. 4 positives, 1 negative. I got to balance. So carbon, and then you get chlorine. Oops, Cl4. I need 4. 4 times negative 1 will give me negative 4. Negative 4, positive 4 will be balanced. Aluminum becomes positive 3. It loses all 3 electrons. Oxygen still likes to gain 2, so we become a negative 2. We're back to that whole 6 again. I need 2 times 3 will give me 6, so aluminum 2, oxygen 3. Beryllium loses 2, becomes a positive 2. Sulfur gains 2, becomes a negative 2. This one's really easy. I'm going to draw it over here, though. It becomes BeS, beryllium sulfide. Sodium loses its 1 electron, positive 1. Fluorine gains a negative electron, and it becomes negative 1. Negative 1, positive 1 will balance out. This one's pretty easy. It is literally just NaF, sodium fluoride. Same stuff that's in your toothpaste. Silicon has 4, becomes positive 4 in this case. Neon doesn't form an ion, so this one doesn't work. Alright, guys and girls, I wanted to make sure you guys had the answers for these. I'll be seeing you shortly.